Hey Bob, thanks for coming in today. Nice, looking forward to talking to you.
Good to see you, Glenn. I wanted to ask you, I get asked all the time, and I'm wondering your perspective, will this new wave of wireless cannibalize fiber?
It's an interesting topic, right? It's been discussed over and over, but at the end of the day, fiber will win out. You got to have fiber connectivity, or you can't beat the connectivity and the bandwidth that you get with fiber. Not that there won't be more radio involved and some radio backhaul, front haul. I think that'll have a bigger play than it perhaps did in the past.
Right.
But again, that's point to point and our line of sight, I should say, and that's very difficult to get when you're trying to densify the network the way we are. Where fiber is available on every street corner, or at least it will be by the time we're done. And if you can get that connectivity, then you offload it from the radio spectrum quickly. So I think fiber's here to stay.
Yeah, so do I. And I think this next wave of wireless deployment is going to drive a lot of fiber.
It is. I mean, that's where you're seeing in our One Fiber program, the fiber, the count numbers, the strand counts are much, much higher than they used to be. And it's not only that they shared in some cases, but it's because of all the different applications we see that can be supported on fiber. So it's not just the 5G antenna, it's the 4G expansion or small cells that we're putting in, it's the business customers, the residential customer, it's our own infrastructure. Everything can be supported on fiber, and that's the goal that we're trying to do, is put in enough strands so that we can support all those services.
So we looked a little bit at the cost associated with having to build for a one fiber network where you provide multiple services. You'll need more fiber, as you just described. You'll need more access points in the network. So there's incremental cost in building a network that's capable of doing that. But there's also cost avoidance. So not having to come back and incrementally build to a building or to an MDU or some other entity that wants service. You're going to keep coming back over and over again, and that's going to cost a lot more in the future.
Exactly. So it's the construction cost it adds up really, really fast, and it takes a lot of time as well, where putting in enough fiber day one means that because it's a long build cycle, a long life cycle for fiber, something that you're going to put in and hopefully not replace for another 30 or 40 years. Therefore, you need to look forward to what you might put onto it in the future.
So tell me a little bit about the wireless architecture that you're planning to build. I know that you mentioned you'll be using CRAN, and I'm curious to understand a little bit more about how that architecture is going to look and any other help that you might need to make it work the way you want it to work.
Sure. We believe in the CRAN architecture, centralized radio access network, because it positions us well for the future. And we're not new at it either. In the East, where we're the ILEC, we've used our conventional central offices for an inside HUD application where we pull the baseband units from neighboring towers back into that HUD location for small cells mostly that we've been building. We want to do the same for macros and certainly for 5G. But then you've got a centralized location where you've got reasonable space, power, and connectivity so that you don't have to spread that out all over the network, and you can share that asset. Again, this is in the ILEC footprint where we had central offices all over the place. We have 2,200 central offices-ish from DC up through Boston, and we're leveraging that asset. So we're looking at, well, how do I expand that out? Saying, I've got facilities other places, albeit maybe wireless facility or a Verizon business facility or Verizon telecom facility. Let's leverage all of our existing assets, put one fiber in the ground, and pull that baseband unit back to those locations, perhaps build more or whatever it takes, or convert some. How's that? Convert a lot of them. But making that centralized resource available to all of the services we sell, and therefore leveraging that asset.
As a fiber supplier, connectivity supplier, we're trying to get ready for this type of build. And there's still a lot of unanswered questions about what exactly is that architecture going to look like. And for us, the impact of the number of fibers at an antenna site, or is it CRAN or not? So we're trying to get ahead. And what we really would love to better understand, what does that architecture look like? Because if you decide you're doing 24 fibers at an antenna site or 48 fibers at an antenna site, that's twice as much. And you've already committed to 20 million fiber kilometers a year for the next 3 years, and that's a big number. And so we're trying to get ahead a little bit and understand what is that demand going to look like, and how might it change? So understanding that architecture is critical.
Yeah, we've created a heck of a partnership over the next couple of years, and that was, I think that was very beneficial on both sides, because we see it as, if we can't get the material, then there's no way to achieve our vision. And I'm sure that from your end it was, well, if I don't have a decent forecast, how in the world am I going to meet it? And I think that was a great partnership. I think of a model going forward to say, here's what we want to go do, and we're willing to make a commitment if you're willing to be the good partner and step up to the task and deliver it when we need it. And you're right, it is dense fiber, and the numbers are, let's say that it's 24 or 48. What we're trying to do is look at, what are we going to need to supply at that tower? And are there multiple tenants on that tower? Or will they be in the future? And therefore we want to prepare for serving other customers that are going to be there. Again, it's a multi-service network. It'll supply everything that we do will go over that same fiber. So that's wholesale services, that's residential services, that's business services, and certainly our own wireless. So it's a bit hard to predict. One of the more interesting models is smart cities. So I think that from a tower perspective, we can figure that out. We've got quite a bit of experience. It's smart cities, Internet of Things that are challenging, because nobody's really done that before. And it's one thing to just throw more at it, right? Everybody can over-engineer it. It's how do you do a good job or a smart job, or use your best judgment in trying to put the right amount of fiber at the right location. If you just guess at it, you're bound to be wrong. You know how that's going to go. So that's the one that's more challenging. One of the studies we did here just recently is we looked at downtown Boston. And we said, what would be the most demanding service case we could possibly have? And it was industrial strength Wi-Fi or outside Wi-Fi. And those antennas turned out to be about every 15,000 square feet. Wow, that's pretty challenging, I mean, that's a lot of fiber at a lot of different locations, non-conventional locations, in parks, on street corners, wherever. And then so T.J. Shaw, Dr. Shaw, who did the study, went right outside of Boston to one of our first Fios areas. And it's a densely populated area, but he figured, well, how many fibers did we put in there? What did we do? How did we attack that problem? And we actually have a fiber placed every 10,000 square feet, effectively, as you divide things up. And so you go, wow, that's not too bad. We've been there before, and we can do this if we go into them with the right mindset. You have to have, if you look at the fiber that's deployed today, it's just not dense enough. But if you look at it from a perspective of, I really do want to light up every light pole. I really do want to get fiber into the park. I want to look at power over fiber and all these other things that we've been talking to you guys about. It's pretty neat or pretty interesting in how you can attack the problem.
So when we think about the demand for products, having that antenna density, understanding that, what you were describing, is critical to understanding how that's going to scale over time, and how and what products those might be. So we know there are options, right? So you could buy more spectrum, and you can reach your performance goals with that, where you can continue to densify the network.
Actually, Wi-Fi is the most critical, or the most resource conservative. So that would be the most density that you need. Now the problem there, and this is where do you want to do it for yourself, or do you want to be a provider in that area, is not everybody's going to want to use those same locations. And so then it does get divided up, and you do want to be able to support other service types. And on top of that, industrial strength Wi-Fi or outside, you also want to light up street media, you want to light up kiosks, you want to light up businesses along the way when you were getting to that location, and that drives the additional strand count.